Welcome to Hui's Podcast. I'm your host, Hui. Today, we are delving into an astonishing topic, a scientific comparison you may have never imagined: the universe and the brain. Yes, you heard it right. Our universe, the expansive celestial domain that encompasses all our known and unknown galaxies, stars and planets, and our brain, the marvelous organ that drives our thoughts, perceptions, sensations, and all possible creations. This comparison might seem strange, even unbelievable. Yet, this unique parallel is not unfounded. In 2017, astrophysicist Franco Vazza and neurosurgeon Alberto Faletti embarked on a cutting-edge study, a rigorous scientific comparison of the universe and the brain. Their goal wasn't to seek philosophical meanings, but out of scientific curiosity for the potential similarities between the complex structures and networks of these two systems. Their work primarily revolved around viewing the filamentary network of the universe and the neural network of the brain as complex networks, then comparing and analyzing the statistical relationship from small-scale fluctuations to large-scale structures. Simply put, they were observing how the universe connects galaxies and how the brain connects neurons, attempting to discover similarities between the two. In this process, they found many interesting similarities, visually and also in data and structure. Their research sparked a new and unique perspective on the universe and the brain, leading to a deeper understanding of the cosmos. So, in the time ahead, we will dive deep into the research by Vazza and Faletti and explore the mystical connection between the brain and the universe to see how these scientists discovered these similarities and how this might impact our understanding of the universe and ourselves. Of course, we will also bring in other scientists' views for a more in-depth discussion on the topic. Sit tight. We are about to embark on this mysterious journey to explore the magical linkage between the universe and our brain. Before we delve into the similarities between the universe and the brain, let's review the research by Vazza and Faletti. Their method involves comparing the filamentary network of the universe with the neural network of the brain. These filamentary networks are the cosmic structures composed of galaxies, black holes, nebulae, etc., and the neural networks are the brain structures made up of neurons, synapses, axons, and so forth. Their goal was to find structural similarities between the two and then analyze the implications of these similarities. They discovered that there is a self-organizing tendency in both the small-scale neural networks and the large-scale cosmic filament networks, meaning these networks show self-similarity in shape and structure. In other words, no matter from what angle or scale you observe, you will find they exhibit similar patterns and forms. This is a fascinating discovery because it implies that despite the vast difference in their scales, their internal organization methods have remarkable similarities. In their 2022 study, Vazza and Faletti further identified other resemblances. They found a similar ratio between the radius of neuron nuclei and the length of its connected axons and dendrites, as well as between the radius of superclusters and the length of its connected filaments. In other words, these networks, whether on a cosmic scale or biological scale, display similar proportional relationships. Furthermore, they also discovered similarities between the clustering coefficient of neurons and superclusters. This is an index that reflects the connectivity between nodes, indicating that these networks strive to optimize their connectivity and stability, even under different scales and backgrounds. All these findings are astonishing as they reveal a deep connection between the brain and the universe. These connections are not merely visual, but extend to structural relationships across various scales. In short, a 1 mm sample of the brain structurally looks similar to a 300 million light-year sample of the universe. However, this doesn't mean that the brain and the universe are identical. Although their structures and organization methods have striking similarities, their operational mechanisms are fundamentally different. The brain communicates through electrochemical signals, while the universe interacts through gravity and other fundamental forces. But this magical similarity provides a new perspective to understand our brain and the universe, possibly offering new clues to solve some unknown questions. We continue to focus on the breathtaking similarities between the brain and the universe. To a large extent, these similarities exist because, despite their vast scale difference, one being the 1 mm neural network in our brain, and the other being the colossal 300 million light-years scale cosmic web, their structures exhibit remarkable congruity. This scale-transcending similarity captured scientists' attention upon discovery. They compared the neuron network of the brain with the galaxy network of the universe, and found these two seemingly unrelated systems show startling congruence in their topological structures. Whether it's how neurons connect or how galaxies interlink, both follow a similar distribution pattern. But we must note that this similarity could just be a coincidence. After all, the universe and the brain, while sharing structural similarities, are significantly different in terms of material composition, formation process, and operating mechanisms. The universe, made up of galaxies, stars, black holes, operates on physical laws, while the brain, made of neurons, synapses, axons, is a product of bioelectrochemical processes. However, another possibility is that this similarity reveals some mathematical inherent relationship we have yet to understand. Perhaps, whether it's the brain or the universe, their organization structures are guided by some fundamental mathematical principle, a principle that generates similar structures in different scales and material systems. If this speculation holds, we might find clues to understanding the universe in brain research, and vice versa. Whether it's a coincidence or reveals a profound mathematical similarity, we need deeper research to unveil its secrets. There are still many questions awaiting answers about this mysterious scientific phenomenon. Maybe in the near future, we will gain a better understanding. At that time, we might rethink what the connection between the brain and the universe truly means, and how this connection could affect our understanding of ourselves and the universe. As we delve into the enigmatic similarities between the brain and the universe, we need to embrace some bolder conjectures. Physicist Sabine Hossenfelder offers us a fresh perspective. Hossenfelder, a renowned theoretical physicist, always enlivens her thinking with innovative imagination. When grappling with the similarity between the brain and the universe, she puts forward a rather audacious idea that superluminal signals might play a crucial role in the universe's thinking. Yes, you heard correctly. She is indeed discussing the universe thinking. This expression might seem somewhat surreal, but if we envisage the universe as a vast network, we can employ the term thinking to describe the communication and processing of information within this network. So, what exactly are superluminal signals? According to Einstein's theory of relativity, the speed of light is the fastest at which information can travel in our universe. However, Hossenfelder proposes that, under certain special circumstances, information might be conveyed at speeds exceeding that of light. If this hypothesis holds true, it offers a novel vantage point from which to comprehend the universe's thinking. Yet this remains just a hypothesis. We know that quantum entanglement in quantum mechanics can facilitate instantaneous information transfer, even over thousands of light years. Therefore, if quantum entanglement exists between galaxies in the universe, information could indeed travel faster than light. Additionally, Hossenfelder mentions wormholes. These are theoretical cosmic structures that might connect two distant points in the universe. If wormholes exist, information could travel through the universe at speeds surpassing that of light. This offers another possible explanation for the similarity between the brain and the universe. However, we must comprehend that these ideas from Hossenfelder are still in the hypothetical stage. We need more research and experimentation to explore whether these superluminal information transfers truly exist, and how they impact the structures of the universe and the brain. Regardless, Hossenfelder's bold conjectures undoubtedly present us with a fresh perspective for pondering the mysteries of our universe. For these audacious speculations, we need the backing of empirical science. Neuroscientist Bobby Azarian and several other scientists have already started exploring in this direction, attempting to find evidence of a difficult-to-understand coherence between distant phenomena in the universe. Azarian is a prominent neuroscientist who focuses on the cognitive and emotional processes of the human brain. He observed that even neurons far apart in our brains can communicate and process information in special ways, which led him to wonder if a similar coherence might exist between distant galaxies in the universe. In the quest for evidence of this coherence, Azarian refers to a 2014 study. This study found that the rotation axes of quasars belonging to different galaxies within a supercluster complex actually aligned. This implies that these quasars, spread billions of light years apart, have their axes pointing in the same direction. A revelation that astounded the scientific community as our existing physical theories struggle to explain this phenomenon. This discovery of alignment could provide some evidence for Azarian's theory of cosmic coherence. It hints that objects in the universe might maintain some form of connection, even across distances of billions of light years. This connection could be a crucial element of information transfer and processing in the universe, and may be key to understanding the similarities between the universe and the brain. However, this too remains a hypothesis. We need more observation and research to further verify whether this coherence truly exists and how it affects the structures of the universe and the brain. In this process, we might need to reassess our understanding of the universe and the brain. Perhaps we will discover that the similarities between the two are not just superficial in form, but may extend to intrinsic connections and coherence. Facing the mysterious resemblance between the brain and the universe, we can't help but delve into the reasons behind it. Scientists have presented us with two possible explanations. Let's explore them together. First, some conjecture that this similarity might stem from the magic of evolution. It's a pervasive phenomenon that affects everything we see, from the form and function of organisms to possibly the grander scale of the universe. Evolution is a process of advancement, a pathway towards optimization, which applies not only to organisms, but potentially to the universe as well. Hence, our universe might also be undergoing a process of cosmic evolution, gradually forming structures similar to those we observe in our brains. Secondly, the theory of self-organization is equally captivating. It's a ubiquitous phenomenon that appears in every corner of nature. Neurons and neural networks in the brain, as well as galaxies, clusters of galaxies, and superclusters in the universe, seem to be masterpieces of self-organization. However, we still need more evidence to support these hypotheses. Evolution and self-organization are just the explanations we can currently conceive of, yet they can't answer all the questions. For instance, why do the brain and the universe, which differ so vastly in scale, bear such similar structures? Next, a more audacious idea surfaced: the universe thinks. This hypothesis sounds mysterious and is perhaps more of a perspective of thought than a verifiable scientific proposition. Yet, that doesn't mean it merely holds entertainment and conversational value. Our Einstein once said, "Imagination is more important than knowledge." This idea might inspire us to pose new questions, seek new research directions, or even alter our understanding of the universe. At this moment, I'd like to quote a classic passage from Carl Sagan's renowned book, Cosmos.
Our passion for learning is our tool for survival. We are built to court wonder. We are formed to feast upon the mysteries of the universe, to savor the unknown. Our ancestors understood origins by extrapolating from their own experience. How else could they have done it? So the universe was hatched from a cosmic egg, or conceived in the sexual congress of a mother god and a father god, or was a kind of product of the Creator's workshop, perhaps the latest of many flawed attempts. And the universe was not much bigger than we see and not much older than our written or oral records, and nowhere very different from places that we know. We've tended in our cosmologies to make things familiar. Despite all our best efforts, we've not been very inventive. In the West, heaven is placid and fluffy, and hell is like the inside of a volcano. In many stories, both realms are populated by beings who are only slightly less human than we. The physical reality of the universe has been most imaginative just where we have not been able to see.
I believe that Carl Sagan's words beautifully depict our pursuit of the unknown and our exploration of knowledge. They remind us that, be it the brain or the universe, we yearn to understand them and seek their truths. This is the essence of science and the driving force behind our constant exploration. We're exploring the similarities between the brain and the universe, a journey brimming with the unknown. This is the charm of science, the very fountainhead of our thirst for discovery. The resemblance between the brain and the universe unveils a mysterious wonder, perhaps hinting at a deeper understanding of the cosmos. So what conclusions can we draw from the similarity between the brain and the universe? An even larger question arises. Does the universe possess consciousness? Does it have its own mission? We know that the brain is our tool for thinking, perceiving, and experiencing the world, the vessel of our consciousness. Therefore, a universe that seems so similar to the brain, could it possess a form of higher consciousness we can't comprehend? These questions might sound like the plot of a science fiction novel, but they might, in fact, lead us towards a new direction in research. The journey of science is a process of continuous questioning, exploration, and searching for answers. Every groundbreaking scientific discovery starts with a seemingly impossible question. Just like Newton's curiosity about the falling apple, Einstein's puzzlement over the constant speed of light, their inquiries ultimately changed our understanding of the world. Thus, I want to encourage you with this story to remain curious about the unknown world and stay passionate about the questions that seem hard to answer. Perhaps one day, you'll stumble upon a question, an observation, a thought that will open up a new field, overturning our understanding of the universe, or even of ourselves. This is the challenge we face, but also our opportunity. Whether the universe has consciousness, whether it has its own mission, we will continue our exploration and keep seeking answers. It's our mission as human beings, as well as scientists. Let's look forward to the next groundbreaking scientific discovery together and witness a deeper understanding of the universe, the brain, and life itself.